G'day everybody, it's Charlie again, just listening to the New Zealand NZART transmission on the Sunday night.
90th year of operation. Conference is to be held over Queen's Birthday weekend. That's the 2nd and 3rd of June at Burns Lodge, 89 Church Street in Mosgiel. Full details about
Let me just transfer that across onto the computer software, and then we'll just talk about that. So if I now just push play on that. Right, so that's lower sideband being decoded using SDR sharp, using the microphone input, which is taking audio directly from this direct conversion receiver. So we'll just transfer it back and I'll talk some more about it. Let me just mute that because it's now the microphone.
Computer was soon to be installed. Well, the day has finally arrived and I'm now using the upgraded system.
Alright, let me turn the volume down. We'll talk about what we have here. So, when we last spoke, we were looking to put together a receiver front end for the SDR rig. And what I wanted to do, I wanted to base it on two NE612s, which is here. So NE612 there, and an NE612 there. We have the SI5351 clocking the SN74HC74, which is then a dual D flip-flop arrangement, and then that's outputting on those two yellow wires there quadrature clock or quadrature oscillator signals to feed into the NE612s for mixing. And as we discussed in the last video, the output of the SI5351 is running at 4 times our desired frequency. So this is a direct conversion receiver. At the moment, just for test purposes, the output of those two mixers, and we'll look at the circuit diagram in a sec, is feeding through two isolation transformers. So this was called notionally the in phase, and this is the quadrature. This is a 1000 ohm to 1000 ohm audio transformer, and I'm just introducing that in preparation for feeding into the Teensy, just to cut any earth loops. And at the moment the audio is coming out through this black wire, coming back around and in through here, and being fed into a simple audio amplifier, which is an NE, say again a 2N3904, feeding into a LM386. And then through the black and white wires through to our speaker. Now this switch here, so this is only at the moment monitoring, as you can see there's only two wires, it's monitoring just one of the outputs of those two mixers. The switch here allows me to switch and monitor the other one. So at the moment we are monitoring, well, I don't know which one it is, but it's one of those two. If we flick the switch, we're now monitoring the other one in terms of the audio output. So it's pretty well balanced because you see you don't hear any difference. If I go in the middle, it will cut off, which makes sense because not one of them is now feeding into the audio amp. So it's one, and the other. And as we heard before, by unplugging this, so that's the audio that's coming out of this direct conversion receiver, I then fed into the computer to use SDR sharp. So what else we got here? So just for testing purposes, and certainly for the direct conversion receiver, like any receiver, bandpass filter. So at the moment I've got the RF coming in, just going through a very simple RF amplifier, which can be either in circuit or bypassed. That's the same amplifier we used in a couple of rigs ago. It may or may not remain in this particular rig, but I just wanted to boost the RF coming in just to make sure I was actually getting something coming through. That's feeding into one of two bandpass filters. At the moment the switch is in this position. It's an 80 meter bandpass filter, and if I was to flick it to the other position, we now have a 20 meter bandpass filter. So 80 meters. and then that's feeding into an RF splitter. That there is an FT 50-43. In fact, maybe this is a good opportunity just to have a quick look at the logic of the circuit, and we can talk from there. So that light's not too strong. So we have, as we just discussed before, the RF's coming in through our RF amplifier, that one here, in through our bandpass filter, and into our RF splitter before it's being split, the RF to our two mixers, the two NE612s, and then the output is a simple low pass filter. The NE612, the configuration for that, nothing special here. You'll see this used over and over again. I'm running this at 7 volts. If you look at the spec sheet, the range is, in terms of the graphs, between 6 and 8. So I've just a sort of a bit of fat running at 7 volts, I should say. And per the spec sheet, through a 6.8 microfarad capacitor and 100 nanofarad decoupling to earth. So pin 1, so it's 1, 2, 3, 4, 5, 6, 7, 8. So pin 1 at the moment on both NE612s, if we were to zoom up, is unused. So at the moment pin 1 is this electrolytic capacitor here. That will be used on transmit on both mixers. Let me get both into view. So our transmit RF, our transmit audio is going to come in through on pin number 1, which is the one of the two inputs on an NE612. Pin 2 is our RF input for both devices, coming in through there on the 100 nanofarad capacitor. So the output of the splitter there, you can see there, one coming through there and one coming through there, through the orange wires, and then in through pin 2. Pin 3 is earth, pin 4 is an output. We'll be using that output on transmit to feed into our power amplifier. Pin 5 is our output for the input on pin 2. That's audio frequency, so that's coming through, just going through a, at the moment, just a junk box 10 microfarad capacitor, and then a simple low pass filter running at around 10 kilohertz at the moment. So two 100 nanofarad capacitors and a 1 millihenry fixed inductor, and that's where you can just see, if I was to move that wire there, just down in here. So audio is coming through that simple filter, and then straight into the input of that transformer, and same on the other side. The oscillation transformers, as we mentioned, are 1K to 1K, and then that RF splitter is an FT 50-43. I would have used a 37-43, but it's just a little bit too small, so went to a slightly larger size. An 8-turn on the primary, and the secondary is a bifilar 8-turn with a centre tap, which you can see there. So we just zoom up on that again. I'll move that test wire. So you can see there the bifilar coming through, centres tapped, and those two outputs, which is what we see here. The earth is in the centre, and then the outputs coming from those 2 points there. So
from Cobus Island between April 6th and 8th.
that's sounding quite good at the moment. So
Sideband and digital mode. USLB is a bureau. Club logs OQRS or logbooks of the world for direct via PY2.
So I think I'm pretty happy with that. I'm not getting any noise from the rotary encoder coming through, which is good. So at this stage of the game, I'm not too sure what else I'm going to fiddle around with. Of interest, we talked about wanting to run the oscillator input for the NE612s, which is coming through on pin 6. Just remember, this is a 5 volt device here, this SN74HC74, so it's outputting close to 5 volts, so 0 to 5 volts. And ideally, the spec sheet talks about 200 to 300 millivolts peak to peak. Of interest, the experimental methods for RF design, if you look at their chapter on direct conversion receivers, they talk about the NE612, and in their experiments they actually had the best performance when it was running at 0 dBm, or just over 600 millivolts peak to peak. So that's what I've currently got this set to. So what I did, I took the output. I initially had, if you recall, a 20 k ohm variable potentiometer to earth, and then the wiper was being fed into the 612, and I got really quite poor performance out of that. So what I elected to do in the end was simply have in series between, so this yellow wire coming in, going through, in this particular case it worked out to be a 4.7 k ohm resistor, was enough to drop that 5 volt peak down to 600 millivolts, or 0.6 volts, and that, as you can hear, seems to be working quite well. So just for interest's sake, I'm just going to go to dummy load on the input. So that's a little bit of leakage coming through on the antenna tuner up the top here, but that's basically with no antenna connected, and then back to antenna.
On the broadcast now, time for Waro News.
So what else is of interest? So we talked about 4 times clocking this. We're getting the output, once it's been divided by 4, is our desired frequency. So at the moment we've got a frequency of 3.9 megahertz. So that's what's eventually coming out on those 2 yellow wires there, which are being fed in through the 4.7 k ohm resistor as the oscillator input to the NE612. What else? No, I think that's probably all for now. Any questions, please sing out. I was looking to use a Talo detector for comparison, but there's a couple of comments that came in about potentially making this suitable for 20 meters as well. That's why I got a 20 meter filter in here. From what I can understand, and I have played with that in the past, that Talo detector, certainly with the 4052 chip, can actually, its performance certainly drops off at around that sort of 14 megahertz. So at this stage of the game, I'm just going to stick with just not comparing the NE612s against anything else, and just stick with those for now. So I'm sort of quite happy with that. And as we say, what we'll do now is the output of those 2 transformers, we're now going to feed through down into the audio input of the Teensy, and then we'll start on the software side. So we'll start on some basic just feed through. So we'll just have the audio coming in and going straight through the speaker, and then we'll start to introduce some digital signal processing to essentially carry out our phasing receiver. Certainly the way the software is working on the computer, no problems with the quadrature signal coming out in terms of our audio. So that's working well, and like I say, oops, better plug it in, that'll be why that's not working.
28 NZART, which has its next meeting on Wednesday, April the 4th. At the
so again, just coming back to the computer just for interest's sake. So now we can just plug the into the microphone input, and then we can push start.
North Shore Branch 29 NZART. The next meeting will be on Monday, April the 9th, at the usual place.
And we can sort of tune up and down and do that. So 390.
Manager with the NZDF, who will talk about emergency information handling. And finally to Hutt Valley Branch 18 NZART, which is a movie night on
That's up sideband, our lower sideband.
which is in the service lane off Bird Street in Waterloo.
It's quite interesting using this SDR sharp, the going here for the IQ from the sound card, which is the input, as opposed to, let me turn that volume down. It's certainly quite different from a sensitivity point of view from for example, the RTL SDR as an input. But I know I'm starting to ramble on here a bit, so just chatting. But I think right. Well, that's the official transmission from the New Zealand NZART just finishing, so that's probably a good sign for me to probably finish as well. So I'll leave it there. Any questions, please sing out. But like I say, I think at this stage of the game, we've got an RF front end here, at least for experimenting, which is working fine. We know we're getting good audio coming out. At least the commercial software on the laptop is decoding that quite happily. So I think now it's just a matter of feeding that into our Teensy, and we'll start doing some DSP on that and start getting into the phasing techniques and see if we can't do the same using much simpler software on that little Teensy board there. Right, otherwise that's probably enough for now. I'll probably look at cleaning up this board. We'll take off this test amplifier, probably leave this in situ for now. And at least a test later on our 20 meters. So that's probably enough. 73s everybody. Like I say, any questions, sing out, and we'll see you next time as we continue to play around with this. Cheers all.